Okay, so I want to go through pretty much in, I guess, really good detail what I'm expecting you to do on a problem like this, where you're trying to prove something's continuous or prove that something's discontinuous at a particular point. And this is example number 2. And I do say, use the definition. If you remember, the definition has 3 parts to it, right? You have to show that the limit from the left, the limit from the right, and the actual function point equal each other. But you have to formalize that into the language, like, I guess, communicate that formally in the language of calculus. So there are 3 components that I need to have you do to get full credit on the AP exam. So first is you just do what I just said, limit. So I'm going to do the limit. So maybe start bullet point 1, limit as x approaches your point in question, which is 1, right? Saying 1. Limit as x approaches 1 from just the right of our function. So you have to sort of like make it a complete sentence. So what is the limit as x approaches 1 from the right of f of x? Equals. Now, you can either rewrite this like as an intermediate step. So like 1 squared plus 3 times 1. Or you could do that part in your head, but you still have to tell me what that limit is equal to, which is 4. Okay, then step 2. You say, okay, what's the limit as x approaches 1 from the left of the function? And again, make sure you're writing your limits, make sure you're writing your functions. And again, you could write out this part, so 5 minus 1, but ultimately you still have to tell me it's 4. Tell me it's 4. Now, that's only 2 pieces. That tells me that from the left it goes to the same point and from the right it goes to the same point, but it doesn't necessarily say there's not a hole. It just says the limit exists. We need to make sure that hole is filled in. And it might seem redundant to you, but we actually have to find what is f of 1. And notice this is not a limit. This is the actual function value. In other words, we have to say the limit value is equal to the function value. What is f of 1? Well, I know we've already calculated it right here, but just tell me f of 1 equals 4. Now, all 3 are the same. So based on showing those 3, I can say thus, f of x is continuous, and feel free to abbreviate continuous like that, at x equals 1. Okay, must have that. Now, you could have more elaborate ways of saying that, but ultimately, this is all you need. It's a very simple way to express that. That is all you need. 3 things: limit from the left, limit from the right, and the function value. You must show all 3 steps. Okay? Now, if for some reason one of them doesn't match, then you've just proved it's discontinuous. Okay, so again, I'll go and do one more example here. 3 things to show. Okay, limit as x approaches 3 from the right of f of x. So you have to tell me what you're doing. Can't just put in 3 and give an answer. You have to actually formally state it. So x approaching 3 from the right. So that's 5 times the square root of 3 plus 1. So that's 10. Okay. Then I can say next step, limit as x approaches 3 from the left of the function. So I go to the left function. So I have 3 squared plus 2. That's 9 plus 2. 9 plus 2 is 11. And as soon as you get here, I don't even have to do one more step. As soon as I say, wait a minute, 10 does not equal 11, right? The limit from the left does not equal the limit from the right. So I could say thus, or therefore, f of x is not continuous at x equals 3. I've just showed that the limit from the left was equal to 11, and then the limit from the right is equal to 10. So clearly they miss each other. There's a jump discontinuity. Okay, I guarantee that you'll see that on your first assessment, and it often comes up on the AP exam as one of the components of a free response question. So limit from the left, limit from the right, and the function point itself all equal the same value. If you have any questions on this, certainly please let me know.